Hello everyone. Unfortunately, due to travel restrictions, I'm not able to be with you in Avignon. Hence, I'm providing this pre-recorded presentation about needs and innovation opportunities for decommissioning using digitalization and robotic technologies. The Institute for Energy Technology is an independent research foundation providing research and development in the fields of renewable energy, nuclear and materials technology, digitalization, radiopharmacy and health, oil and gas, industry and environment, as well as safety and security. IFE is also the host of one of NEA's longest international collaborations, the oecdholden HTO Human Technology Organization project, providing a continuation for the earlier OECD HRP Holden reactor project. Within the field of nuclear decommissioning, IFE was also the first organization to be designated by the International Atomic Energy Agency, IAEA, as an international collaborating center. Our research program related to the IEA Center is focusing both on research, facilitating digital transformation of nuclear decommissioning, as well as facilitating exchange of knowledge on an international level through organizing workshops, trainings, and other events in collaboration with the agency. It is worth mentioning that in the context of digital transformation, we are also looking at robotics and specifically on how robotics and digital technologies can mutually enable each other. There have been a number of international initiatives that included analysis of needs and innovation opportunities within nuclear decommissioning. I have been involved on various levels in a number of these. In the following slides, I will quickly introduce these activities. The oecdholden reactor project. Within this project, we performed interview discussions with organizations involved in nuclear decommissioning during the previous 3-year HRP research program. As mentioned, the HRP research is now continued under the new name Holden HTO Human Technology Organization Project. Our Nordic study, supported by the Nordic Nuclear Safety Research, was performed in 2017 and 18 and focused on mapping common challenges and good practices among the Nordic countries. The results of this work are available online under the name indicated on the top of the slide. IFE, under the Norwegian government's Action Plan for Nuclear Safety and Security in Russia, Ukraine, and other countries in Eurasia, has been supporting several decommissioning sites and projects since 1999 and ongoing. These projects included adoption of digital concepts and systems for the specific needs of various sites and projects, revealing practical needs of field operators. LifeDecom and Robotic are Norwegian-financed industrial innovation projects with participation of international organizations. In these projects, we also performed discussions with experts aiming at eliciting needs and innovation opportunities in nuclear decommissioning, including those related to application of 3D simulation-based digital concepts and their integration with modular robot systems. The Pleiades Horizon 2020 project aims at demonstrating a modular software ecosystem based on interconnection of frontline support tools through a nuclear decommissioning specific ontology, building upon Open BIM, Building Information Management standards. The Pleiades survey focused on innovation needs specifically related to application of such modular software systems. Pleiades is presented on this event in a dedicated presentation. Digidecom is a workshop and training series we organize annually in collaboration with the IEA, NEA, and other partners, always including interactive group discussions about needs and innovation opportunities in nuclear decommissioning. In 2021, Digidecom was organized in collaboration with the SHARE, Pleiades, and Pleiades Horizon 2020 projects, the group discussions providing valuable input to these European projects. Finally, I would like to mention the NEA's recently formed EGRS expert group on application robotics and remote systems in the nuclear backend. This group has also performed surveys in the form of questionnaires and, in collaboration with DigiDecom, moderated group discussions. EGRS is also presented on this event in a dedicated presentation. The before-mentioned surveys confirmed the following general challenges and needs in nuclear decommissioning. There is a slow-paced adoption of innovation. There is a need for joint investment in research and pilot projects for enabling a faster global adoption of these innovations. The most common recurring keywords related to technology-based innovation are digitalization, as well as robotics and automation. There is a foreseen shortage of skilled staff. Harmonization of training and education on a national and international levels are needed to ensure an adequate future supply of suitably trained workforce. The international knowledge base should be extended to more open sharing of knowledge, including on a practical level, and higher standardization of processes. Waste management is an important area where international harmonization is highly needed. International harmonization of safety standards and regulation is needed, as well as flexibility and alignment of regulation for enabling easier adoption of innovative methods. Here are some dominant trends related to digital transformation. Applications are usually limited to specific, usually safety-critical jobs, for instance, digital training. Digitized facility configuration management, DEM approaches, are more generally applied, but they also need to be adopted to the nuclear-specific needs and requirements, and integration is required with complementary technologies. There is an emerging interest in integration of BIM and other digital systems with safety, risk analysis, and robotic systems-related technologies. Potential of the community is shifting from one-fits-all complex solutions towards modular concepts. As for dominant trends related to robotics, current applications are mostly limited to heavy-duty robots working segregated from people in usually highly hazardous jobs. Emerging solutions need to be verified and potentially customized for the nuclear-specific needs, for instance, considering needs for hardening, including radiation hardening, secondary waste, maintenance, and other issues related to the life cycle. There is a high interest in modular, reconfigurable robot systems and ecosystems. And finally, there's a high need for more intelligent robots and cobots, providing more safe and efficient human-machine interfaces for the humans supervising them. The two common themes identified across these surveys that we are mostly focusing on are: one, the holistic digital transformation, including integrated modular multi-purpose ecosystems, holistic lifecycle management approach, as well as BIM, building information modeling and management, and knowledge-centric plant information-based concepts. And two, robotics, specifically modular, multi-purpose ecosystems, soft-compliant robots and cobots, natural telepresence, and intelligent systems enabled by machine learning and AI. In fact, our focus is on exploring opportunities for better integration between robot and digital systems, especially but not exclusively in environments where conditions may affect human health and/or the operation of robots, for instance, radiological environments. We are now in the process of establishing a new lab dedicated to such activities under the name HADRON, that stands for Hazard Aware Digitalization and Robotics in Nuclear and Other Domains. In conclusion, I would like to convey three takeaway messages. Based on the surveys mentioned before, we concluded that while we see an increasing number of examples for new applications for digitalization and robotics in general, introduction of these technologies in nuclear decommissioning is still challenging. Three topics that I would like to highlight that I think are key for facilitating a higher momentum for technology adoption are modularity and standardization, and specifically development of suitable knowledge representations and information architectures, enabling standardized integration of related technologies. Addressing digital and robotics-based transformations together in development of safety and business cases for future nuclear decommissioning approaches. And finally, exploiting synergies and applicability of technologies and approaches across domains and industries to improve both the business case and attract young talents who expect to work with these latest technologies. Regarding point number 3, we are, for instance, looking into application of digital and robotic technologies that are applicable to nuclear decommissioning in maintenance and decommissioning of oil and gas and other installations, response to incidents at hazardous sites, work in labs and installations related to fabrication or shipping of dangerous substances, and even production of radiopharmaceuticals. Thank you for your attention, and I would be very happy to take questions and discuss with you if it wasn't for the travel restrictions. However, please don't hesitate to contact me on the email address that I indicated on the slides. Thank you.